Okay, this next problem is on the page for elimination or the addition method, but notice how we have an x by itself here. It is much more easily done using the substitution method. So I'm going to take that second equation, substitute it into the first equation, have 4 times input minus 2y equals 6, and substitute this in 1/2 y plus 3/2. And I'm not going to bother clearing the fractions because they're about to clear in my distribution. 4 times 1/2 y is 2y. The next part of the distribution gives me 12 over 2, which is plus 6, minus 2y equals 6. And notice how, when I combine like terms, those two y's cancel each other out, and we are left with 6 equals 6. When you get a true statement such as this, we are going to say that there are infinitely many solutions to this system. Now, it's important to use this vocabulary. You cannot use the words all real numbers. Okay, now the reason we don't use all real numbers is our solutions are not numbers. They're coordinate points where lines intersect. So all real numbers, the word numbers is bad. And so we want the phrase infinitely many solutions to be what we use. Okay, here's a bit of a challenging problem for us. It says, find the value of k such that the system of equations does not have a solution. Well, you do not have a solution when the two lines are parallel. And when are two lines parallel? Well, when they have the same slope. So we need to find the value of k so that each of these equations has the same slope. And that means taking each equation and putting it into slope-intercept form. So the first equation is ky minus 12y, that's kx minus 12y is equal to negative 10. And the second equation, negative 15x plus 10y is equal to negative 19. I'm just rewriting them all over again so that I can put them at the top of the screen. Now for this first one, we want to solve for y, which means subtracting kx off of each side. We will have negative 12y equals negative kx minus 10. And then we're going to divide each side by negative 12. That will give us y is equal to k 12ths x plus 5 over 6, where the slope here is k over 12. In the second equation, we will have 10y is equal to 15x minus 19 after we add 15x to each side, and then we will divide through by 10 on each side of the equation, and that will give us y is equal to 3/2 x minus 19/10. Well, 3/2 is the slope of that line. We set up above that we want these to have the same slope, and we want to know for what values of k will these two slopes be the same. And that means I want to equate these two slopes and write k over 12 is equal to 3/2. Well, we can solve that very easily by cross multiplying. We will have 2k is equal to 36, and therefore k equals 18. In other words, when k is equal to 18, those two lines will be parallel, and therefore the system will have no solution.